Mountain in Crafting Interpreters by Rob Nystrom. Just wanted to mention before I get started that I primarily do these streams to kind of keep myself focused and motivated in going through this book, and I'm not very good at finishing projects that I start, so I want to keep myself more accountable and finish these projects. However, I also would like to find ways of making this content helpful or of interest to others, whether that be watching the live stream or watching the recordings. So if you come across this video and would be interested in seeing me do this live and you have suggestions on how I could do that better, please let me know. Or if you have suggestions on how the recording could be made better with edits and such, please let me know that as well. One thing that I did actually realize, and I'm going to fix that right now, is the recording recording quality wasn't great. So let me fix that right now real quick. Let's see. Edit. Settings, there we go. Stream. General. Video. Output. Okay. Well, I'll try and get that fixed for next time. Try and get the recording to be a little higher quality. I actually just streamed this directly to Twitch, and then I export the recording directly to YouTube. So there's recording never actually touches my computer, which I don't really have the most powerful computers. So so that's actually a less of a burden for me. Anyway, let's get started. We're only going to do a really short section today. We're going to do while loops, which there isn't much to it here. And if I feel like it at the end, then maybe we can go back and revisit truthiness and falsiness, which I have not implemented. So let's take a look at while loops here. Locks features two looping control flow statements, while and for. The while loop is a simpler one, so we'll start there. Its grammar is the same as in C. Just add a while statement to this list of statements here. With a while including an expression and then followed by a statement. We'll add another class of statement rule that points to the new rule for while. It takes a while keyword, followed by a parenthesized condition expression, then a statement for the body. That new grammar rule gets a syntax tree node. The node stores the condition and body. Here you can see why it's nice to have separate base classes for expressions and statements. The field declarations make it clear that the condition is an expression and the body is a statement. Over there in the parser, we'll follow the same process we used for if statements. First, we add another case and statement to detect and match the leading keyword. That delegates the real work to this method, and the grammar is dead simple. This is a straight translation of it to Java. Speaking of translating straight to Java, here's how we execute the new syntax. While is truthy, execute statement body, return null. Like the visit method for if, this visitor uses a corresponding Java feature. This method isn't complex, but it makes locks much more powerful. We can finally write a program whose running time isn't strictly bound by the length of the source code. Okay, so we read the entire section. Most of it will be in the implementation now. The starting part, this bit will be very easy. So we can actually jump all the way down to pretty much this bit right here. Now this bit is super simple in implementation, but it's going to be a little bit harder in OCaml because OCaml doesn't have while loops. So we're going to have to figure out how to implement that instead. Let me just pin this real quick. All right, let's go take a look at that now. So let's go over to our parser. Really easily, we just add a while to, we'll do it after this if here. We'll say while condition statement, and then we have to add that to the AST. And we'll do that in here. Expression and statement. We'll now go over to the print AST because that's going to be yelling at us soon. I don't really care too much about this, but I have to maintain it anyway. And then we go to eval. Eval is where we have to implement it. So for eval, for now, what we can just say is what is this while? Is there actually a while in OCaml? I didn't think there was. We're just going to, okay, B here is a statement, C is a statement. Are they both statements? While statement, no. C is an expression. So let's just say eval expression scope C. And for now, we'll just ignore the B that's there. Okay. Let's run it just to see where we are in this. Okay, this not liking it here. Expression is type expression, but expression was expected of type unit. Oh, okay. Then in this case, we can just do yeah, pipe it into print. There we go. Okay. All right, so we're at a place where at least everything compiles. We have the while statement in there. Now we actually have to implement it. So Copilot was hallucinating there a little bit and saying that there is a while statement. While. I don't know if that's true or not. OCaml while. I think we're going to have to do some recursion of some sort here. The interpreter is complaining about line 4, which is done, and I have no idea what is wrong here. While a is less than 10, the let in constructor expects another expression behind it. You can, for example, use the... So the code will compile with the loop indefinitely because the a defined as 1 at start is different than the a declared as a plus 1. Both are constant different values on different scopes, and a declaration inside the body of a while is limited to that occurrence of the body. Okay, interesting. So here's what so they do have a while loop here, which I suppose is good news. But the interesting thing is what we're actually evaluating the while here is an expression. And I suppose that expression could change. Yeah. Yeah. Okay. So I suppose we just do while eval expression scope C do eval statement. Is it a statement inside? Yeah, it is, right? Execute statement.body. It's just a single statement. Okay. The statement could be a block, which is fine. Do eval statement scope B. Okay. This expression has type expression, but expression was type of type bool because it's in the condition of a while loop. Aha, okay. So we need to say equals literal true. Literal, what's the AST for this again? There's a literal of Boolean of true. Something like that, right? Okay, that looks like it should work. Okay, let's give this a try. Let's say okay, we'll do let a equal, no, not let, it's called var, right? Var a equals 0 while a is less than 10. This has to be in a less than 10. Open up the braces, right? Does it have to be braces? No, it just has to be a statement. So we can just do at this point, no, actually, we do want to open a block. We'll say a is equal to a plus 1, and we'll do print a. There we go. Let's see if that works. Whoa! Okay. So that went to an infinite loop. This is kind of what I was afraid of. So at this point, it evaluated a, then it goes into this while here, right? So this while statement, I don't, okay, let's see how this is implemented in this one. Evaluates the statement, then executes the statement body. Yeah, we're definitely have to get to do an is truthy here, but execute statement stop body. Okay. Eval statement scope B. So this is going to say while, and it's going to do this thing where it's evaluating the statement with B. Then B is going to be another one of these things like a block, for instance. We are doing the thing where so here we are reassigning A, but is A being reassigned in the same scope? That's the thing that I'm kind of wondering about here. Is A in a different scope here? Are these the same A, in other words? How could I verify that? Well, I suppose I could not do a block there, because whenever I do a block, that's when I'm creating a new scope. So I could just say, A is equal to A plus 1. And then we'll just see if this terminates. It does terminate. Okay. So in this case, it knows that A is in the same scope, and it's incrementing it correctly. But when we put it in a block, A is being referred to in, so I think this is a mistake in how I'm doing assignment. Yeah. So here when I'm assigning, I'm just taking the current scope and assigning it directly in that scope. What I need to be doing is saying, look for where this thing exists. Figure out which scope it exists in, and then assign the value in that scope. So let's fix how assignment works here. So replaces the current binding of key in table by binding, if key is unbounded, binding of key to data is added to table. So we don't really want replace there because we don't want it to just add something itself. Let's see what else we have here. Clear, reset, copy, add, find opt, find all, mem, remove, replace, iter, fold, length, randomize, is randomize, rebuild, Stats to sequence, add sequence, replace of sequence. Okay. Hash to hash. Okay. So I guess what we really want to do is a find first. And if we find it, is there like a has key? Just checking to see if the key exists in the hash. I suppose that's just what find is, right? But it raises. It'd be nice if we could do something that we can pattern match on. Hash table, add find opt. Oh, find opt might do it. Let's see what that does. Hash table dot find opt. Returns the current binding of X in table or none if no such binding exists. Okay. So let's see how we want to do this. We want to do if it's a current block, we want to find it. Let's do a let here. Let's say let no, okay. We want to actually do a match, right? We're going to do match hash table find b id v with exception not found. Let's do a find opt instead. And then we'll do a none. I suppose this would actually be a good place when we actually find it to do type checking and say, hey, you can't reassign this to a new type, but that's not actually what we're asked to do anyway. We have to make this recursive now. Okay. And we just want this to be parent. And we just want this to be parent as well. This one doesn't like it. This match case is unused. Because this matches anything. So if I just swap those two, then it'll hit the none first. Cool. I think that works. So now this is saying, like, make sure that you replace it in the correct place, essentially. If we find it, then we replace it in that scope. Otherwise, we keep going up to up to the future higher scope. At this point, if we get all the way up to the global scope and it doesn't find it, it's just going to pop it in the global scope, which I'm fine with for now. But that's actually not the semantics of the book. It said that we're supposed to implement. Okay, so let's see if that still compiles. It does. Now let's go back and see if we can print this. Print A. Look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very cool. That's great. Pretty happy with that. We got while loops working. Figured out a flaw in the assignment along the way. I think I'm gonna call that a night. I'll come back and re-implement truthiness and falsiness. There's a lot of holes in in my implementation right now. More things around error checking and the truthiness and falsiness, but I'll come back to it at some point and we'll clean it all up. Again, if you have any comments on how I can make this more useful to you or to anyone else who might be interested in watching it, please let me know. And if you could follow me on Twitch or subscribe to my YouTube channel, that'd be great. Thanks.